Welcome to the Trellix Spotlight series. My name is Nick, and I will be your host. Today's session will focus on an overview of the ePO-SaaS Threat Events API. This webinar will be recorded. If you prefer not to participate in the recorded session, please feel free to disconnect at this time. A link to today's recorded presentation will be emailed to all registered attendees. This webinar is a brief overview covering common use cases and scenarios regarding this topic. It is not intended to be all-encompassing. If assistance is needed, please contact Trellix Technical Support. If you have questions during the webinar, please type them in the Q&A window. This webinar may run longer or shorter based on your participation, and we recommend asking as many questions as you can to make the most of this series. If the Q&A window is not displayed, click the tab at the bottom of your session window and click on the Q&A icon. We will answer the questions during the final section of this webinar. If you experience any audio issues during the webcast, please drop and attempt to reconnect. Our speaker today is Travis Merritt. Travis is a staff customer success engineer who started his career at Trellix in 2013. Travis has been supporting ePO on-prem in various roles throughout his tenure and began supporting ePO-SaaS since its initial release. He primarily focuses on handling case escalation as well as providing training and coaching to our support teams. Ladies and gentlemen, Travis.
Thanks, Nick. Today I'm going to start by giving you a quick overview and background discussing why we have published an Events API, as well as what benefits it gives to ePO-SaaS administrators. I'll also be giving a detailed instruction on how to structure the HTTP requests you need to use to implement the Events API within your environment, and guidance on how to identify and fix some of the common failure conditions you may encounter when using the API. Using the API is effectively a two-step process. Step 1 is to obtain your authorization token, and step 2 is to structure a GET request to actually download the event data you need. The GET request does require specific parameters to be included, so I'll be covering those parameters and how to use them. This information should give you the foundation building blocks you need to begin working with the Events API. Ultimately, to make the API useful in a production environment, the HTTP commands that will be demonstrated today would need to be included within a custom script or a third-party application that can automate the calls and reliably fetch the event data. However, creating such a script and scripting examples are beyond the scope of this presentation. So why use the Events API? The Events API, or an application programming interface, is a REST API which provides access to threat event data in your ePO-SaaS tenant via HTTPS. The most common use case for leveraging the Events REST API is to feed your third-party SIEM or syslog receiver with event data generated by your managed endpoints. In the current implementation of ePO-SaaS, there are no options to register a server to upload or forward event data to. This is distinctly different from those of you familiar with on-prem ePO, which uses a registered syslog server as a method to feed event data from your on-prem ePO server to your syslog or SIEM. In an on-prem ePO environment, an API is not required to accomplish this. So as an alternative to a registered server for ePO-SaaS customers, we have published this API, and it is offered to any customer that has an active trial or paid subscription that includes ePO-SaaS. I will note here that if you do not already have an ePO-SaaS tenant, you can follow the Sign Up Now link from xconsole.trellix.com. ePO-SaaS does allow users to create custom queries to obtain event data and export that data. However, an additional reason we offer the Events API is due to the architecture of the product. The only option to export query and report results containing event data is via an email attachment of a CSV, XML, HTML, or PDF. Event data exported from the ePO-SaaS UI cannot be saved directly to a file or file share. It must go through email. While these queries and reports can be scheduled to run and export the results as an automatic server tasks, there are a couple of functional limits at play with this approach. One such limit is that the email attachment included in an exported query cannot exceed 40 megabytes. Using an API to pull event data from ePO-SaaS overcomes this limitation. So how does the API work? The API has a dedicated event data store that the event data is fetched from. When an event is received from a managed endpoint, part of the workflow to process that event is to parse the event data into two different data stores. The event goes to both a Dynamo database that the API can access and read from, and the same event file is also stored in a SQL database that the ePO-SaaS console UI reads from. While the data stores are separate, the same event content exists in each of these data stores simultaneously. It is important to note that the retention periods for these data stores are different. The data store the ePO-SaaS UI reads from retains 1 year worth of event data, When you run a query for events, the query results can include event data up to 1 year old based on the event generated time. The data store the events API reads from retains 3 days worth of event data. The oldest event you can fetch with the events API will be up to 3 days old. When implementing the events API to get events out of your ePO-SaaS tenant, you need to plan on fetching events on a near real-time basis, as you'll not be able to fetch more than 3 days worth of event history per GET request. Authentication to the event data in your tenant is handled via a JSON web token, otherwise known as a JWT. The first step to successfully fetching event data is obtaining that valid auth token. Once you have successfully obtained your auth token, you can then invoke an HTTPS GET request for the desired event data. The GET request must be configured to use one of the region-based events API URLs, and this is based on the data center your tenant is hosted in. There are currently 5 regions: US, Singapore, Frankfurt, Sydney, and India. I'll explain how to determine your tenant region as well as which specific URL you'll need to use when writing the API a little later on. But first, I want to demonstrate how to obtain the access token used to authenticate the API. The access token is obtained by sending an HTTPS post request to our IAM token system at iam.mcafee-cloud.com. This is a common URL across all tenants and regions that is used for getting a token. Within this request, you'll need to include specific data and header information so that a valid token can be returned. This method of requesting a token requires providing a username and password of an ePO-SaaS user that has been granted proper permissions to read event data from the tenant. My advice here is to plan on creating a new API user or service account in your tenant dedicated for this purpose. This helps avoid any potential issues that might arise from using an account of an actual person in your organization, as that individual might be a multi-tenant user or may move to a new position and no longer need access to your tenant. With an explicit API user account defined, the API user you create can be static and assigned to a role or permission set that only includes access specifically to what it needs in order to pull the data you require. Let me open up my test tenant and show you how I have my API user and role configured. So I'm going to go ahead and log on here to the authui.trellix.com. And once the page is loaded, I'm going to navigate to Menu, Users and Roles. All right, now for the purpose of this demonstration, I've added an account already called API Webinar using a shared mailbox api.webinar@trellix.com. Right now, this user has full Trellix ePO administrator permissions. However, because it's only going to be used for getting event data, we can restrict that down a bit to make it slightly more secure. So I'm going to create a role for this purpose. Call this events API user. And we're going to give it 2 specific permissions. The first will be the ePO reporting permission. And specifically in here, we need to include the view thread events permission. The other that we're going to include is for data loss prevention incident, the view incident reports permission. All right, so this creates our role. We'll go ahead and save that role. And then we can assign that role to our API webinar user. So we'll go ahead and remove the admin permissions and grant the events API user custom role and save that. Okay, and for now, log out of this tenant. All right, coming back to our slide, you'll also need to include the user's client ID. This can be found by navigating to the authui.trellix.com/support URL and logging in as the user. So what that would look like is it will show you, that page will show you a information about the user's token that they're currently logged in with, as well as some information about the user's account on the right-hand side of the screen. So this is an example of what you'll see. From the right-hand side of the page, you'll see the details about your user. And again, in this example, I'm using api.webinar@trellix.com. So scrolling through that right-hand side of the page, you'll find the client ID value, and this is what you would take to use in your token request. So we'll go back to the table with the parameters you need to include. The next value to include is the grant type. This must be set to the value password, as this post request is being used to complete what's called a resource owner password credential flow. The final data parameter that you'll need to include is the scope. Now, the scopes define what permissions the token will include. There are several options that can be used at this step, with some overlap between the options. Deciding which scopes to include in your request depends on your specific end goal and which type of event data you need for the API to return. Generally speaking, it is best to work with the least privileged approach. So for example, if you only need to fetch threat events, use the scope ePO-EVT.R. Whatever scopes you request will be embedded into the token. A token request that includes the ePO.admin scope could be used to carry out any actions against the tenant that there is an API published for. Note that there are additional APIs published which can only be used if your tenant includes the proper SKUs. However, accessing those SKUs, those APIs, is done through a slightly different method. For the events API, though, you can combine multiple scopes in this portion of the post request. So for example, if you want a token that includes read access to both EPO events and DLP incidents, you can use the scopes ePO-EVT.R and DPIM.R together. So as you'll recall, I granted my user api.webinar.com at Trellix.com a limited role that only included those two permissions. So from the auth.ui.trellix.com support site, we can see what scopes are applied to the user based on the roles assigned to the user. And again, since this user only has the ePO-EVT.R and DP.IM.R scopes assigned through IAM, these are the only scopes that can be included in a token request using this user's credentials. All right, so finally, when assembling the request, you need to include three headers. That's going to be the header for accept, content type, and cache control. And the values you need to set are listed here on the table at the bottom of the slide. So once you put all the pieces together, this is what a completed token post request should look like. Here, these two examples of what show running from curl in the command prompt on a Windows 10 machine, as well as curl from terminal on a Red Hat Linux server. I want to point out and demonstrate this difference in these because in support, we occasionally see syntax issues with respect to the quote characters. In Windows implementations of curl, the URL and parameters need to be wrapped in double quote characters, otherwise the command will fail, with the curl error 3, which is URL using bad or illegal format. This syntax requirement will vary depending on how you choose to implement the API. You can see from the examples that I'm running an HTTP post with each of the parameters and headers. I used data right here to point out. You can see the mouse on screen. I used --data--URL encode for the scope because there's a space character in here that needs to be properly encoded. Otherwise, everything that was on the previous table is here in this particular curl request. Once that request is submitted, what you expect to get back is the token, or the auth token. So the response to the post command is this bearer token. The access token in this example is the string of characters that starts with EYJ. This string is what will need to be included in the API GET request. The other response that is important to take note of is the expires in value. Tokens requested in this method are now valid for 3,600 seconds or 1 hour. Once the token expires, it will no longer be valid and will need to be refreshed by issuing a subsequent post command. If you decide to create a script to implement the Events API, be sure and account for the token expiration in your script. So there are a few known scenarios that can can result in a failure of the post command to return a valid token. So first and foremost is syntax error I just mentioned. And this syntax, again, is dependent on the version of curl and the OS you're running the request on. And so if you're using curl on Windows, the URL and parameters should be wrapped in double quotes. If you see the error there, curl-free, URL using bad label format or missing URL, then you need to check your use of the quotes around the URL and parameters. When defining which scope to include in the token request, the user must have the roles applied that grants the corresponding scope. For example, in order to request the ePO.admin scope, the user must have the Trellix ePO administrator role assigned in ePO-SaaS. To request the ePO-EVT.R scope, you must have the Trellix ePO reporting view threat events role. And to request the scope dp.im.r, your user must have the data loss prevention view incident reports permission. If you request a scope that user is not authorized for, the response error will state no scopes available for this user. And that will prompt you to go double check the roles assigned to that user. The invalid credentials error can occur for two different reasons. The first one is because our IAM password requirements do require special characters when initially setting up your password for your ePO-SaaS user account. Certain characters, such as exclamation point, can be treated as an escape character in terminal or shell sessions, and certain scripts. The fix here is to include the -data-URL encode option for the password parameter in the command. If your tenant has been configured with a third-party identity provider for single sign-on, and your user account is marked as SSO required or not exempt, then the token request will fail with the error, no tenant ID available. This method of obtaining a token requires that the user is exempt from SSO and is allowed to log on using their ePO-SaaS username and password. The tenant admin owner can adjust a user's SSO status from the tenant settings page, which I will show you in a moment. The next consideration here is the MFA, or two-factor authentication requirements. This can also cause failures obtaining an access token. If your user account is configured for MFA, the token request will fail with the message authentication denied by sign-on policy. There are two places MFA can be enabled within ePO-SaaS. One is the global settings on the users and roles page. If this is enabled, all users in the tenant are forced to configure multi-factor authentication. On tenants where the global MFA setting is disabled, individual users can still opt into MFA within the My Profile page. And I will show you where those are set as well. Finally, if the user account has become locked out due to too many failed login attempts, the token request will fail with the message the credentials provided were invalid. We don't have an explicit error catch for this condition, so if you see this, double check that the password given is correct, and check that the account, check if the account is logged out by simply logging on to the UI. If you see the banner, the UI login screen, that the account is locked, try again later. Then you'll need to either wait for the account to auto unlock, which happens automatically after 20 minutes, or you'll need to contact support to have your account unlocked manually. Let me go ahead and show you those two configuration settings for single sign-on and for multi-factor authentication. So for single sign-on, the tenant admin needs to log into the tenant. And from the upper right-hand side here, you can access the identity provider configuration. All right, so I'm going to go ahead and click edit on this just so it can be a little more clear. The user list here is the list of users that can log on through the identity provider, and exempt users are also allowed to log on through their Trellix username and password. So we want to ensure here that the API user is in fact exempt from single sign-on, and they are. So here we don't need to make any changes, but if you're using an identity provider configuration on your tenant and planning to use API calls, you do need to make sure that the user that you use for API calls has the checkbox selected to exempt them from SSO. This means they're allowed to use their ePO-SaaS username and password. So we'll go ahead and cancel out of this. And then the last thing we need to check for the user is that multi-factor authentication has been disabled. So that is also done from the, like I mentioned, in the users and roles page. And in this tenant, I do have require multi-factor authentication disabled. You can see the slider is set to the off position. So we would just need then to check that the individual user does not have it enabled for their account. So if we log in as that specific user, api.webinar@trellix.com, we can tell it's not enabled because we didn't get prompted for a two-factor challenge code. But that profile setting that I was referring to a moment ago can be found from the logon or from the main menu. If we click this user profile icon here, it'll take us to the My Profile. And in the My Profile, there are options to enable two-factor or disable two-factor. And log back out. Okay, so I mentioned previously that you must submit the API request for event data to the region-based API URL that matches your tenant region. This chart lists the various regions and their corresponding URLs. This list can also be referenced in the ePO-SaaS product guide. However, be aware that the table in the product guide also lists an API gateway URL, which is reserved for the additional APIs that are included from the API SKU. If you have that on your tenant and you have access to developer portal, there's an additional list of APIs that can be used. But for the events API, this API uses these AR events URLs listed on the right-hand side of the table. To determine what region your tenant is hosted in, you can use the Tenant Provisioning Service, or TPS URL that's seen here, along with your actual tenant ID, the 16-digit code for your tenant ID. Just as a brief example of what to expect when you do that, you can pull that up for my tenant. So I'll put a new tab here. Now I have this bookmarked. And if I go to my API partition check, you can see here that this particular tenant is hosted on UI US West 001. And it also lists it over here. The pool is US West 001. So if you do that, run this URL with your tenant ID and include it on the end and check the pool or the UI, you can match the entry to the tenant URL region you need to use. So most tenants are hosted on US West, followed by EU, and then India. So those would be the URLs to use. And we'll go ahead and look at the actual request parameters of the GET request. So once you've identified your tenant region, you can then begin building out the GET request that will be used to fetch event data. This list contains the parameters that the Events API supports. The only two parameters that are mandatory are the auth token and the event type, which the type is used to fetch either threats, DLP incidents, or all. In other words, both threats and DLP incidents. The remainder of the parameters are optional. However, they are useful to help avoid pulling the same event data more than once. The event data on the data store is persistent for 3 days, and it can be returned by the API multiple times. So if you run the same API GET request multiple times, you'll see the same set of results returned. So leveraging the since and until parameters, as well as the after parameter within any scripts you create to run the API, will help you avoid pulling the same event data more than once. It'll also help you avoid skipping any events. When you use the since and until parameters, there's a very specific date format that must be populated. You'll use a 4-digit year, a 2-digit month, a 2-digit day, followed by the specific timestamp. You must include the T and Z characters in accordance with the ISO 86001 date format. You do not have to specify the timestamp of the specific timestamp of an event that was, exists. You can say you want to pull all events that were generated between um, two specific dates, right? You can start with the time of 000000 and end with like 23.59, right? To get all events on that 24-hour period. The sort parameter is the next one on our list, which again is optional. Setting sort to ascending orders the events from oldest to newest by event received UTC time. And setting the sort parameter to descending orders the events from newest to oldest by that same event received UTC time. If this is not defined, the default sort order of descending newest to oldest will be used. The limit parameter defines how many events will be returned in the response payload. This is also an optional parameter, and if not defined, the default limit of 100 will be used. I have a dedicated slide for the after parameter because it requires a bit more explanation. The after parameter is the one that's most useful for ensuring that events fetched via the API are not skipped or duplicated in your response payloads. So as an example, if your script is configured to fetch all events generated in the last 60 minutes, and there are 3,000 events that have been received by EPO in the last 60 minutes, if you're using the max limit of 1,000 events in your GET request, you would need to run the GET request 3 consecutive times to pull all 3,000 events. And that's because at most we can only return 1,000 events per iteration. So each response payload will contain 1,000 of the 3,000 total events, and each response would represent one page of data. So by implementing the after parameter, you can ensure that the second and third and so on executions of the GET request do not skip or duplicate any events that fall between the times each execution of the GET request was run. The after parameter acts like a cursor, kind of referencing or pointing to the last event that was pulled in the prior page of data. Within the response headers of the GET request, not in the body, but the response headers, there's a header key named link. The content of this header indicates if there's another page of event data to be fetched or not. If there's no rel equals next value populated in this header, your GET request has returned all events that meet the criteria defined. So in this table, what we're looking at are the contents of the link header responses. So the response here at the first row shows that there's more pages, and we can tell that because the after the after parameter, there's this entry that says rel equals next. So that's a hint that there's another page of data to be captured. Whereas once we reach the end of pages or end of events in the list, you'll notice there is no rel equals next in the link response header content. There is a rel equals self, but that is different. What is the key here is rel equals next. All right, now once you have the GET request configured, there are a few failures which we see that can be corrected by making a change to the request itself or to the token you're using in the request. If you see an HTTP 403 forbidden message, this is almost always an issue with the token. You'll need to confirm that the token includes permissions to the type of event that you're requesting. So for example, if the token was requesting using only the EPO event.read scope or EPO evt.r, and your GET request was for events type equals all, well, that token does not have permissions to read DLP incident data. So the request will fail with the HTTP 403 response and give you the permissions denied error. In this case, you would need to take one of two routes. You would either need to redo your token request to include both EPO evt.r or dp.im.r or even EPO.admin, or adjust your GET request to only include the type threats that corresponds to your token. Any number of issues with syntax of the GET request could result in an HTTP 400 bad request error. Most commonly, what we see on the support side are that these are caused by failing to include the type parameter in the request at all. This is a mandatory parameter, so it does need to be included. And the other thing that we see is if you included the type parameter but put the wrong value for it. So keep in mind that the type parameter only accepts 3 different values, and that's going to be threats, incidents, and all. And in this specific case, the values are plural, so it's threats with an S and incidents with an S. If you try threat, it won't work. It'll give you the HTTP 100 bad request, or 400 bad request. The last entry you see there is actually a successful GET request. However, it is a bit of a question comes up from time to time about why there isn't any data in the payload. And in this scenario, what that means is that there aren't any events present in the data store that match the criteria that you requested. So an empty response is in fact a successful response. But if you have an empty response and say in a test tenant that you just stood up, one thing you can do to generate some event data right away is to install endpoint security and then use an anti-malware test event like from icar.org to generate a threat event, and then redo your GET request, and you should see that threat event in your payload. So I'm going to show you the API in a demo to help clarify some of the information presented in these slides. So for the demonstration, I'll be using a third-party tool called Postman, which has a nice UI for displaying the structure of the HTTP calls and responses. Let me go ahead and open up that program. Now with Postman, what I've done, I've gone ahead and created a workspace with various APIs, which lets me save those with some populated information. So what we start off with is our HTTP post request to get our token from our IAM server. So this is our initial request, and this is going to be using curl with the www form URL encoded key values here. As you see, we're using our API webinar at Trellix.com user with their password and their client ID that we fetched earlier from the authui/support.html site. Our grant type for this post request is password, so that's our resource owner password grant method we're using. And in this scenario, I'm going to request the 2 scopes, ePO-event.r and dpin.r in my token. The thing I want to point out here is we do have a space separating these two. You don't need to do commas, they just separate each scope by a space. So let's go ahead and I do want to demonstrate also the headers. Postman includes some default headers, but we do have the accept header as well as the cache control header set here. So we have what we need to go ahead and run the request. So what we'll do is we'll send this. And here we get back a valid auth token. Again, the token is the values between these 2 quotes, starting with EYJ. In my case, this will be different. May not be the same every time. Obviously, the tokens are unique, but this is the token right here. We can see also we've got an HTTP response code here. It was at 200. We know it was successful because we got our result that we needed. Now, if you recall, when we started, I took away the EPO admin role from this user. So if I were to try and request a scope with epo.admin, what I would expect is that it should fail. And there we go. So we still got a response back, right? And this time it's 401 unauthorized, and we have some error catch descriptions here. It tells us, hey, that password grant, I can't do it because there's no scopes available for this user. And what that means is that scope that I've asked for is not applied to that user in ePO-SaaS. So if you wanted to use ePO-admin, you would have to go into the users and roles page and grant that user the ePO-admin permission set. But for now, we don't need it to have admin, so we'll go back to epo-evt.r and dp.im.r and get another token. Okay, so that's how we fetch the token. The next step is to issue a GET request. So I'm using, again, a test tenant that has some event data in it, not a lot. There's only 3 systems managed by it that don't really have a lot of activity. So, but we do have some to work with. Um, what we need to do first, though, before we can run this GET request, is provide it our authorization string. So in Postman, it breaks out the parameters and authorization and headers into these different tabs. So we can go to the authorization tab and select a type of authorization. In this case, we're going to use a bearer token and paste in the token that we got over here. Okay, so that token is going to be included in our request. And again, Postman is nice because it automatically sets the headers that we'll need for this. But what was optional for us here is the parameters. Now, I mentioned that the type parameter is mandatory. If we were to try to run this without the type parameter set, we would get a failure. So we'll go ahead and run this as is, basically with very few filters applied, with just the threats parameter, and see what we get. Okay, so down here again is our HTTP status 200, and we actually have our payload. This payload is the raw event format as it was received by ePO-SaaS from the managed endpoint. That event got generated by an agent or ENS or a point product and got uploaded to the handler in the backend. And from there, it got parsed into those 2 different data stores: the actual SQL database the EPO UI pulls from, and the data store the API pulls from. So what we're looking at here is all the content of the event. And Postman is putting it into JSON format for us. If you were to do this from command prompt, it would be just in straight, XML format. It would look more like this, right? So whatever program you're using needs to be able to parse this information and acknowledge the separators between each event. Putting it in JSON format makes it a little easier for us to digest and read. So we can see, fields that you expect to see off an event, such as the received UTC time. The other thing to note is, because this is raw event data, we're not doing any sort of we're not doing any sort of conversion of time zones, right? Like you can do with the EPO UI. So if we were to just look at how many events we have, I believe there's about 60 or so events in this tenant. So you can see the payload in this case, there's quite a lot of event data here. If I search for like a common field, like received UTC, just do a Control F on that, you can see there's 62 entries. Now each event has this search string twice, so really there's about 30 events returned in this request. All right, so we can again add some parameters here, so we could limit the number of results we get anywhere from 1 to 1,000. So we can go ahead and do a limit 1, and that'll return a single event. So our scroll bar here is much shorter because there's only 1 event here. It's the most recent event. Because I didn't include the sort parameter, it's defaulting to descending, so I get the most recent event first. You can see the type is a threat event here. This particular event is an ICAR detection. You see ICAR test file. I can increase that limit to any value I like, up to 1,000. The other thing I want to take some time to demonstrate is what happens when you when you request a different type of event here. So let me switch this around to incidents. Okay, now my tenant does not have any incidents, DLP incident data in it. So that's why we get this blank result, like we showed back on the slide earlier. And then the final parameter to demonstrate is that after parameter, which is a little bit complex, so bear with me on this. I'll try and demonstrate the best I can with only having 30 events present. So we're going to go back to threats, get our entire list of threats. And what I'm going to do is pull the last 6, the most recent 6 events I have to basically create 3 pages of event data. So we'll start by doing a limit of 6. Okay. And we'll get the timestamps of each of these 6 events. So we'll start with the received UTC times. We'll copy these out just to a notepad document here. So there's our first event. And what I'm going to do is just call this page 1. And we'll come back and do our next event timestamp. We'll call this page 2. The next 2 events. And page 3. Okay, so we've got 6 unique events. We can tell they're unique because the received timestamps on each of them is different. So we start here at 21:21, 12:25, and then a different day, or a different hour rather, 15:12, 03:12, 23:13, 2018. And we'll set that aside for the moment. And what I'm going to do is use the since parameter to get all events since this time. Now we know there's only 6, right? So we'll go ahead and set our since parameter equal to that timestamp. And again, that's using that 4-digit year, 2-digit month, 2-digit day, and then the granular timestamp. So if I take off the limit parameter and run it with just the type threats and since equals our date stamp there, we should still get the same 6 events back. And you can see from the search over here, we have 12 hits of this received UTC. If we scroll up to the first one, this timestamp will match our first event page, so on and so forth. So grab the second one just to show you that it is really the same 6 events. So all these values are matching as we go. Look at the last 2. Okay, so we have the same 6 events returned. You can see these timestamps are the same for each of the events. So, and clarity, remove these entries. All right, now say I adjust my limit down to 2. So I get 2 events per page of data, right? So we'll go ahead and send. I'm going to actually clear this out and send this request. Now we've got a result with our most 2 recent events, starting with this one here. And then UTC. See, there's only 4 results this time because there's only 2 events. All right, so we know there's 2 more pages of data that needs to be collected by this GET request. So the way we can tell that through the API is by looking at the headers of the response. So go and look at the headers, and we see in the headers there's this link header. And in this link header, here's the value of that link header. And the clue we're looking for here is this rel equals next. All right, so this is our clue that there is more data beyond the two events we've already received. So to leverage the after parameter, we use this value here. It's after equals. So I'm going to grab this one, place it here, set that to after. All right, so now we've updated our GET request with the after parameter. And I'm going to go back to the body and just clear out our response field and send this. Now this is going to pull down two more events. We search here, a total of 4 hits of that, and pull the timestamp out. This should be the timestamp of page 2, starting here. So this is starting with 11:10, 15, 12, 24. All right, and then we'll go to the next event. And there it is, 03/12/25. And we have one more page of data to get. You can see we reached the end of our search results here. So what we'll do is go look at the headers of the second iteration of the GET request and check the link header. And we see that there is indeed another after and rel next. So we'll grab this new after and update it here. And we'll clear out our back to body and clear this out. And we'll run this one more time. We should get our last 2 events off of the data store. So we're starting with this event, and you can see we're down to page 3 now. And this matches. It's the event from the 9th at 23:13:03. And come down and get the last one of those. All right. Okay. And so we should have reached the end of the page of events. So if we look in the headers at the link token or at the link key, there is a different looking value here. You can see this time the rel next is not present, right? So that's our clue that we've reached the end of the page of data. So that after parameter basically is referencing the last event that was received in the payload. So that way, the next time you issue the GET request, you can refresh the after parameter from the header and ensure that you're not skipping or missing any events. So the very last thing I want to demonstrate is just to show that these are the same events that exist in the UI that are being pulled from the data store. So this timestamp here, 11:09/2018, we can use that to query our thread event log. So I'm going to go back to the tenant. I'm going to log on as a admin user here to the tenant. Okay, we're going to go to the thread event log. All right, we're going to look at events in the last 7 days. Now there's 32 items. What we'll do is we'll apply a custom filter for event receive time, and then we'll do is later than that particular timestamp. Right, so events later than 2018. And there's our 6 events. If we compare these timestamps, they will all match up. So I've got these, I believe, sorted in the right direction. Note that the API is using a 24-hour clock, whereas ePO is using a 12-hour clock for this column. So that's one of the differences, is that, like I said, the UI is going to do some manipulation of the event data to make it more user-friendly, whereas the API, you're getting the raw event data. So if we look, let me just take off this second column. So we start with the first event in the list, the time, hours, minutes, and seconds match, 21:21. and then the next one, 211225, third one, 151224, and so on and so forth. So we're pulling, like I said, from two different data stores, but the same data exists in both places. So this is my recommendation for how to pull event data out of your tenant is to leverage this events API. And that'll allow you to integrate with third-party applications like a SIEM or a syslog receiver. So that wraps up what I wanted to demonstrate today. I'll hand it back to Nick to start our Q&A session.
Thanks, Travis. As a reminder for everyone, Trellix Education Services offers exceptional training to go along with our award-winning products. If you would like to learn more, please visit the website listed on your screen to see all of our offerings. Now let's get our Q&A session started. I see we have several questions, but it's not too late to add your question. Please type it in the Q&A window to submit. Additionally, take a moment to fill out the survey. Your feedback and suggestions are always appreciated. Is there a limit to how many times per day I can request a token or run a GET request?
No, there's no limit on this particular events API. You can run the GET request as many times as you need for your script to pull back all the events you need to get.
Got it. Okay, perfect. Thank you for that one. I noticed in the product guide that it mentions both McAfee and Trellix URLs. Does it matter which one I use?
Right now, those URLs are both dual homed as part of our rebranding efforts. We kept the old McAfee URL live so that customers, that integrated these URLs into their scripts have time to update them. So it would be a good idea to go ahead and update any scripts you do currently use to reference the Trellix URL going forward. The dual home URL is supposed to end in early 2024.
Got it. Okay, perfect. Thank you for that one as well. Do we have any integration with SIM, such as the IBM Q Radar?
IBM does have a marketplace app published to Trellix Marketplace. However, in order to leverage those apps from various providers, you do need to have the API SKU added to your tenant subscription, so that you can integrate those pre-published apps. So if you do leverage that, then you wouldn't need to develop your own script because that marketplace integration can be set up and a lot of the legwork is already done for you. So I know that or rather IBM QRadar does have an app published there, so you may want to look at getting that SKU on an evaluation basis to check that out and see if that would be a better fit than the free API that we discussed here today.
Got it. Okay, perfect. Thank you for that one as well. Looks like we got another question. According to someone that we spoke with in sales, they mentioned that the product license is about API calls, for example, 2,000 API calls. Is this quantity by calls per day?
So that is referring to the API SKU, which is a paid subscription. And that particular API SKU does have a quantity of calls per day tied to it, and that quantity resets at midnight UTC time. And if you need more than 2,000 calls per day, you could stack that SKU. However, I do want to differentiate that the events API we discussed in this presentation is the one that's specifically for events and DLP incidents, and there is no SKU required to use this, and it does not have a limit. The limit would be that it can only pull back events and DLP incidents. If you need additional APIs to, say, interface with client tasks or get device information, system properties, things like that, you would need the API SKU because the API SKU unlocks all of the APIs that are available on our developer portal.
Got it. Okay, perfect. Thank you for that one. Is there a KB article or documentation that you can share that has step-by-step steps or to configure the API?
Yeah, so the step-by-step information for this API is documented in the Trellix ePO-SaaS product guide. There's a specific section on the events API, and it walks you through the how to get the token and the parameters you need to include in your GET request, as well as the table with the URLs that you need to use.
Got it. Okay, perfect. And we'll include that link to the docs page in our post-session email that goes out around 24 hours after the end of this session. All right, perfect. It looks like that's all the questions that we had for today's session. I want to thank everyone for joining today's webinar. And a big thank you to our speaker, Travis. As a reminder, a link to today's recorded presentation will be emailed to all registered attendees. This concludes today's webinar. Stay safe, everyone.